Hello, welcome to Cloud Learning Channel. In this module, we will learn about predictive aircraft engine monitoring. In this module, I'll show you how to combine a real-time aircraft data with analytics to monitor aircraft health. So in this module, we will learn about a list of components that we need to design this predictive aircraft engine monitoring. And I'll show you the architecture and how it works. And I will also talk about the potential use cases. Let's start with the list of components. What are all the components that we need to design this predictive aircraft engine monitoring in Azure Analytics platform? So here is the list. We need Event Hubs, Azure Stream Analytics, Azure Storage, Azure Machine Learning, HD Insight, Azure SQL Database, and Azure Synapse Studio or Azure Data Factory and Power BI. So let me talk about each service before I move into this architecture. Because if you want to know how to deploy all these services, you can please go through my previous module. So there are a lot of modules available in my channel that how to deploy each service. It could be even Hub or Stream Analytics or Storage, and you can deploy it. And if you want to know how this service work and what is this service use, what is the use case for this service in Azure platform. So you can get all those details if you can go to my channel and refer the previous videos. So here are the list of components that we need to design a predictive aircraft engine monitoring. So while I show you guys architecture, I will also talk about this service in detail. So let me move to the architecture. So here is the architecture. So if you see that very beginning that we get all the data from this aircraft engine sensor data, and we receive everything through Event Hub. So let me talk about that Event Hub. So Event Hub ingests a raw assembly line data and passes it on to Stream Analytics. Then this Event Hub is designed to ingest this real-time data in Azure platform. So there are other services also, but in this particular use case, Event Hub is the right service. So there are Event IoT Hub and also Azure supports Kafka. But IoT Hub is more for devices, mobile devices, and this Event Hub, this is the right service for this particular use case. And this Event Hub ingests this raw data and passes it on to Stream Analytics. So once this passes data to Stream Analytics, let's talk about the next step is Stream Analytics. So here you see that on the second step, the first step that Event Hub receives data from this aircraft engine sensor data and passes into the Azure Stream Analytics. So what this Stream Analytics does, it provides a near real-time analytics on the input stream from the Azure Event Hubs. So once it receives the input data, it can filter and pass to a machine learning endpoint and finally sending the results to the Power BI dashboard. So let's talk about this Stream Analytics. And there is one module available in my channel. So how we can bring the data from Event Hub and do the analytics. So we can use the custom SQL and we can add the filter conditions and then we can transfer the data. We can send it to Power BI or any SQL data warehouse or anything, anywhere we can send it. So please go through the Azure Stream Analytics so that you can get a better idea so how the Stream Analytics work. So let's go back to this architecture again. So once it receives data from Event Hub, the Stream Analytics, it filters and passes to a machine learning endpoint and then send the results to Power BI. And once data receives in Stream Analytics, right, you can see that Azure Block. So what is this Azure Block? So like I mentioned, once you complete your or transformations, once you filter your data and you want to store it in Azure storage account, you can use Azure Block. So you can send directly the data from Stream Analytics to Azure Block. So here for Stream Analytics, the input is Event Hub and output is Azure Block. And Azure Blob, what is this Azure Blob? Azure Blob is designed to hold the massive data in Azure. You can store a video or audio file or image file, any unstructured data, semi-structured data. You can store any data in Azure Blob. And once we have this data in Azure Blob, and the next one is HD Insight. What is this HD Insight? So HD Insight runs Hive scripts to provide aggregations on the raw events that were archived by Stream Analytics. So, in this HD Insight, you can use all the Hadoop components in Azure. And what is this Azure Machine Learning for? Here you can see that Azure Machine Learning. Azure Machine Learning predicts potential failures based on the real-time assembly line data from Stream Analytics. So let's go back to the beginning of the architecture. Let's go back to the step one. And here, if you see in the step one event hub, the data comes from the engine sensor and then receives and then send it to Stream Analytics. And here all the data is aggregated, everything, all the data is filtered. And what this machine learning does, it predicts the potential failures based on the real-time assembly line data from Stream Analytics. So the Stream Analytics passes data to Azure Block, and how this machine learning can access. So using machine learning, it can connect to this HD Insight and access all the data and predicts the potential failures. So based on that assembly line data from the Stream Analytics. And here you can see that what are these Azure Synapse Studio and Data Factory. So you can use one of these service. So you can use Data Factory or you can use Synapse Studio. So Azure introduces this Synapse Studio just a few months back, and whatever a Data Factory offers, Synapse Studio offers the same thing. So you can use either one. So what this Synapse Studio or Data Factory do, they handle orchestration, scheduling, and monitoring of the batch processing pipeline. So you can create a pipeline in either of these tools, and you can schedule it. It works based on, you can schedule it event based, or you can just do it trigger, and so you can orchestrate the end-to-end here in the Synapse Studio or Data Factory. And also if the pipelines fail, then you can monitor and also you can rerun it. And it provides all the logs in monitor option. So once you log into the Synapse Studio or Data Factory, you can see the monitor option. So I just made a couple of modules on how the Synapse Studio works. So please go through that module so that you can get a better idea how the Synapse Studio works and how you can build a pipeline, how you can orchestrate and schedule and monitor if the pipeline fails. And let's talk about the SQL data warehouse. So Azure SQL Database stores a prediction results received from the machine learning and published to the Power BI. So here you see that we talked about step one, Event Hub, and then Stream Analytics, and send the data to Blob, and then use HD Insight to provide aggregations on the raw events that were archived by Stream Analytics. And then Azure Machine Learning predicts potential failures based on real-time data from Stream Analytics. So once all these steps are done, and then the Azure SQL Data Warehouse we use to store prediction results received from Azure Machine Learning. So this machine learning can send data to this SQL Data Warehouse where we can store, and you can use Power BI to connect to SQL Data Warehouse and access the data and build the dashboard. So let's move to the last step, the Power BI. So how does this Power BI work? So Power BI enables visualization of real-time assembly line data from stream analytics and predicted failures and alerts from data warehouse. So here you can see that it connects to the stream analytics sending data to Power BI, and also the SQL data warehouse sending data to Power BI. So what's the difference? So the Power BI enables a visualization of real-time assembly line data from stream analytics. And what is the SQL data warehouse? You may ask me, like, what is the SQL data warehouse? And it predicted failures and alerts from it can access the predicted failures and alerts from data warehouse. So you can use this Power BI for these two services. And let's talk about the potential use cases. So if we have the right information, it is possible to determine the condition of equipment in order to predict when we schedule the maintenance for the aircraft. So this predictive maintenance can be used for, like, the list of use cases here in the presentation. You see it, a real-time diagnostics and the real-time flight assistance. If we have the right information, so it can help us, like, to do this real-time flight assistance and also prognostic and cost reduction. And I think I covered all the use cases. I covered each component in the architecture. So before we end this module, so I will quickly review what we discussed in this module. So in this module, we discussed how to design a predictive aircraft engine monitoring in Azure Analytics platform. So the list of components that we need to build this architecture: we need Azure Stream Analytics, we need Azure Event Hubs, Azure Storage Account, Azure Machine Learning, HD Insight, Azure SQL Database, Azure Synapse Studio or Azure Data Factory, and Power BI. And we discussed about how to design this architecture using all these components. We discussed about step by step how we can ingest data from this aircraft engine sensor data and the process to stream analytics. Once we did all the filtering in stream analytics, then we can send it to Azure Storage Account, or using Power BI, we can directly access that real-time data from stream analytics. Once we have this data in block storage, then we use HD Insight to run Hive scripts to provide aggregation on the raw events that were archived by Azure Stream Analytics. And we use the machine learning to predict potential failures based on the real-time assembly line data from Azure Stream Analytics. And we discussed the next steps, Azure Data Factory or Azure Synapse Studio. They help to move data, orchestrate, schedule, and monitor. Then once we have all this data, so SQL database where we store all the prediction results received from the machine learning and published to Power BI. So Power BI can connect to this SQL database and access that prediction results, and we can start build dashboards and everything. And at the last step, we discussed about the potential use cases. If we have right information, so we can determine the condition of equipment in order to predict and when maintenance should be performed. So if you have any questions on this predictive aircraft engine monitoring or any of the services that we use in this architecture, please post your questions in the comment section and I will try to reply as soon as possible. If you like this video, please subscribe and share the channel. Thank you.